Okay, so last we got this cylindrical objects problem. This was invented by Dr. Dell, who just sort of likes to come up with these clever little geometry problems. So the key thing to recognize here is these circles, these cylinders, have a radius of r, little r, and the width of the the container they're in is 3r. Okay, so what this means is that there's a distance of r between their centers, and well, actually, no, there's a distance of 2r between their centers. But if you think about, for example, look at these 2 points I've drawn here, or this little triangle I'm drawing here between these two. Okay, so right there, this is a line. The hypotenuse here connects the center of the bottom one to the middle one. Okay, and then if you drop a vertical line from the bottom one, well, see, this is a width of 3r all the way across. This is r here, and this is r over here, which means the center thing must be r. So even though it doesn't look like it in my diagram, you can recognize this is a 30, 60, 90 degree triangle. Okay, so important point there, because that helps us then to figure the geometry out. Okay, so without further ado, for let's see, I'm going to call this top one. So I'm going to back all that out. Neat. Okay, there we go. So I'm going to call this guy log 1. Okay, so here's log 1. And what forces are acting on log 1? Well, there's log 1's mass times g, of course. There's a normal force at point A, okay, which is pushing it that way. And then there's also normal force where it contacts what I'm going to call log 2 down here. So I'll just go 1, 2, 3. So there's a normal force from log 2 on log 1. And as I said before, this force acts 30 degrees from vertical. Whoops, sorry. It's not theta, it's 30 degrees. Okay? So if we do our standard x, y coordinates, no reason not to, then we're going to have normal force at point A going that way. We're going to have mg going down. We're going to have, going up, we're going to have n21 times the cosine of 30 degrees, which is going to be square root of 3 over 2. Okay? And then going to the left, we're going to have n21 times the sine of 30 degrees, which is 1/2 n21. Okay? So sum of forces equals ma. Okay, so in the x direction, you're going to have n normal force at point A minus 1/2 n between 2 and 1 equals mass times acceleration in the x direction, which is 0. In the y direction, you're going to have square root of 3 over 2 times this n21 minus mg equals mass times your y acceleration, which is 0. Okay, so now solving these things, we're going to find that from the y equation, we're going to find that n21 is equal to 2 over root 3 times mg, right? Yes, sir. Okay, so then we can plug that in up here, and we can get that na is going to equal, well, it's going to be 1/2 of n21, and so n at point A is going to be 1/2 of this 2 over root 3 mg, so it's going to be 1 over root 3. Yep, let's back. There we go. Root 3 times mg. So that's the magnitude of your normal force at point A. And that's one of the 4. Okay, moving on to log 2 now. We're going to have forces going like this. Let's see. We're going to have mass of log 2, which is m, because they're all mass m, like that. We're going to have normal force at point B, which is this one over here, pushing log 2 to the left. And then you're going to have here And here, each at a 30-degree angle, and this is going to be 30. Okay, you're going to have this normal force from 2 on 1, or actually it's 1 on 2, but you get the idea, and normal force of 3 on 2. Okay, so doing this, of course, x, y, we now get, there is normal force at B, there is, let's see, there is n32, it's going to be a 30-degree angle, so it's going to be root 3 over 2 n32. Okay, and I'm going to make this really big, going up, and then this is going to be 1/2 n32. Okay, this is going to be then this way 1/2 n12, or n21, or whatever. Well, actually, I said 2-1 over there, so I suppose I should do that. And then down here, this is a huge dot, but it is still a dot. I stand by that. This is going to be root 3 over 2 n21. Then you've got gravity going down. Holy crap, this is harder than I thought. And that is going to be all of it. Wow. Okay. So, holy moly. All right. Wow, what are we going to do here? Okay, so, well, I guess we write the equations, right? That's what the method is for, to keep us plugging and chugging. So, sum of forces equals MA. Okay, and so in the x direction, okay, in the x direction, come on, where's my cursor? There we go. In the x direction, you know, actually I'm going to, yeah, okay, we're going to go in the x direction. We're going to say, wow, can we? I mean, holy crap, this is, wow, huh. Let's see. You know, actually, I'm going to exercise some discretion here and do the y direction first. Well, it doesn't matter because we've got to write them both out before we solve them, right? But root 3 over 2 n32 going up minus root 3 over 2 n21 minus mg equals mass times acceleration y, which equals 0. Okay? And then the x direction, we've got 1/2 n32 plus 1/2 n21 minus n at point B equals mass, right, times acceleration x, which equals 0. Whew, okay, so what I want to do now is I'm going to switch to green now and take the y equation first and plug in the value we got earlier for n21, which is 2 over root 3 mg, right? This is n21. That was the normal force. Remember before, that was the normal force that 2 exerted on 1, right? And so then the normal force that 1 exerts on 2, which is this n21, should be the same, just in the opposite direction. And that's how we've done it. Okay? So inserting that for this n21 here, root 2 or 2 over root 3 mg, means that what we're going to get is root 3 over 2 n32 minus, and then this was 2 over root 3. Well, I'll tell you what, I'll just write it out. Okay, root 3 over 2, that's a 3, times 2 over root 3 mg minus mg, all that equals 0. Okay? And this becomes just minus mg because the 2 and the root 3 cancel. And so what this is going to get us is that root 3 over 2 n32 is equal to 2 mg. Okay, so now we know that, come on, n32 is equal to 4 over square root of 3 times mg. Needless to say, there will not be a test problem that involves you going through this much stuff. Because, I mean, wow, right? Okay, so now that I know that, I'm going to take the x equation, and I'm going to switch to this sort of baby blue thing here, okay? And plug that n32 in, and our n 2-1 from before. So 1/2 times n32, which is 4 over root 3 mg, okay, plus 1/2 times 2 over root 3 mg, okay, minus nb equals 0. And so what that gets us is that nb equals, and this is going to turn out to be a cancellation, 1 over root 3. This is going to end up being 2 over root 3. So it's going to be 3 over root 3 mg. Wow. 1 over 3, 1 over, well, that's right. Okay, so that's an increase. I mean, I guess MB is more than NA, which makes sense, I suppose. Oh, come on, damn it. Okay, there we go. Okay. Finally, geez, oh, Pete, here. Okay. Finally, what we got to find out is D and C. Now, an interesting thing we could say here is I will bet you almost anything that the normal force at D, which is going to be going up vertically, is going to be equal to the weights of all these three. So if you think about it, think about drawing a box around or free body diagramming all three of them, okay? So if you take all three of them together, so we're going to do an FBD of 1 plus 2 plus 3, okay? And look at the diagram. I don't have it on the page right now, but I can see it on the paper, and you can see it. What force is going to be acting on that? Well, you're going to have, of course, M1, M2, and M3 all massed together times G. So your weight is going to be 3 mg. Okay. Going up, the only force going up will be the normal force from the bottom. And I believe I'll label the bottom point D. Okay. So, yeah, and normal force at point D. There we go. Okay, 3 mg. Okay. There's 2. And now going to the right, you have the normal force at point A and the normal force at point C. Going to the left, you have the normal force at point B. Now, maybe you don't see this yet, but let's go through some forces equals MA. And what you're going to find in the x direction, you have NA plus NC, minus NB equals M, well, actually it's 3MA, right? 3 mass times their x acceleration, which all equals 0. And we already found out what NA and NB were, right? So now we can solve this. Let's solve this x1. Well, I'll tell you what, we'll do y first, okay? So y, now you've got ND going up, minus 3 mg